Hey everyone, ready to dive into some Unity game optimization?
We're going to make those games run like a dream.
We're tackling Unity games optimization best practices today, breaking it down so everyone's on board, even if you don't speak fluent code.
Think cheat sheet to shipping a successful game, minus the technical overwhelm.
Exactly. It's about making a game that not only looks the part, but performs like a champ too.
Yeah.
And that starts even before you open Unity, right?
Absolutely. That pre-game prep is crucial.
It's more than just, having a killer game idea. It's like planning a road trip. You wouldn't hit the gas without knowing your destination, right?
Exactly. And can those scenic routes handle your vehicle?
Yeah.
The guide really emphasizes researching those target platforms early on.
Yeah, makes sense.
You might be surprised, like instance rendering. It's super cool for efficient rendering, but guess what? Not supported everywhere.
Oh, really? I didn't know that.
Yeah, so many devices. So knowing your limitations from the get-go is like step one.
Makes those early decisions so important.
Huge. And just like you don't want to overload your car, memory and performance budgets, got to set those early.
Easy to get carried away, though, right?
Totally. The guide compares it to like overpacking a suitcase. Let those memory limits spiral out of control. Crashed game.
Oof. Yeah. Speaking of spiraling out of control, let's talk about the development process itself. How do we avoid those pitfalls?
Avoiding disaster. Planning is key.
I'm all about efficiency. You know me. What's the secret sauce for a smooth development process?
Think about automating your day-to-day. Coffee brewing while breakfast cooks itself.
Okay, now you're talking.
That's automation and version control in game dev. Handles repetitive tasks, tracks those code changes. Lifesaver when you're collaborating.
Especially with a team keeps everyone in sync.
Huge, yeah. Large Unity scenes, single ones, can be a nightmare for teams. Guide stresses, breaking those levels down. Smaller, manageable, way smoother.
Bite-sized pieces make sense.
Yeah.
And while we're on the topic of things that can make a game go haywire, gotta address the fixed time step setting.
Ah, yes, that one trips people up.
Okay, it sounds a bit ominous, gotta say. What's the deal with this setting?
So controls how often Unity's updating the physics, right?
Mm-hmm.
Default is 0.02, that's 50 updates per second, 50 hertz.
Okay, keeping up 50 hertz.
Might be fine for some, but physics-heavy games, performance nightmare. We're talking the dreaded spiral of death territory.
Spiral of death. Okay, yeah, that sounds like something we want to avoid at all costs. What's happening there?
So it's all about how that fixed time step plays with your game's frame rate. Lag starts, those physics updates, they pile up.
Oh, that doesn't sound good.
More lag, glitches, the whole shebang. Finding the sweet spot where those physics updates match the game's speed, that's key.
Smooth sailing from there on, hopefully.
Exactly.
Now, how do we make sure things are running smoothly in the first place?
We profile, my friend.
Ooh, profiling. Time to put on our detective hats. I like it.
You got it. It's like giving your game a health checkup. Tools pinpoint those performance bottlenecks.
So we can fix them up.
Exactly. Unity has its own built-in profiler. Plus, you've got those platform-specific ones, too.
Gotta love options.
Right. And just like your own health, don't wait till it's an emergency.
Prevention is key, yeah. Gotta stay ahead of those bugs.
One of your best tools, the Memory Profiler, visualizes how your game's using memory. Super useful.
So it's like a map highlighting memory hogs, or what?
Exactly. Clear picture. Textures, meshes, sounds, which assets are taking up the most space. You can then see, like, oh, is that texture unusually large? Maybe some import settings are off.
It's like finding a hidden treasure chest that reveals the secrets to optimizing our game's resources.
That's a great way to put it.
And speaking of those resources, let's talk about assets and how they impact game performance.
Right, the building blocks of our games. They got to have those high-quality textures, the models, but got to use them strategically too, right?
It's like that balance, visual fidelity versus performance.
Exactly. And, the guy points out, textures, those beautiful, beautiful images, they're often the biggest memory hogs.
It's like having a gourmet kitchen. You want the best ingredients, but you don't want to overcrowd the pantry.
Perfect analogy.
Yeah.
And one sneaky culprit, that read-write-enabled option for textures.
Oh, yeah, I've seen that.
Useful for some tasks, but it doubles the memory footprint, essentially.
Like ordering 2 of everything when you only needed 1.
Exactly. Unless you're absolutely sure, keep it unchecked.
Good to know. Now, speaking of optimization, we can't forget the heart of our games, the code.
Ah, yes, code optimization, where even small tweaks can make a world of difference.
Absolutely. It's all about clean, efficient code, not wasting those precious resources. And the guide highlights the Unity player loop here.
The player loop, it's essential to understand.
Okay, player loop sounds a bit technical. What exactly is it, and why so important for optimization?
Think of it like the conductor of an orchestra, okay? Dictates when different parts of your code get executed, keeps everything running smoothly.
Gotcha, keeping the rhythm.
Exactly. And two key methods within this loop, update and fixed update.
Right, we touched on fixed update earlier with that whole spiral of death scenario.
Right.
But how does update fit into this whole orchestra?
Update. That's your steady beat, your metronome. Happens every single frame.
Reliable.
Yep. Ideal for player input, animations, anything needing that consistent timing.
Makes sense.
And fixed update, as we said, tied to that fixed time step, your separate clock for physics calculations.
Okay, I'm following. Now, what about common mistakes? What do developers often trip up on?
Now, there's a big one, synchronous loading. It's like waiting for the water to boil before you even start chopping veggies.
Holding everything up.
Exactly. Leads to loading screens, performance hiccups. No bueno.
We want things to run nice and smooth.
Exactly. Asynchronous methods, that's the key. Load those assets in the background, keep things moving.
Like a well-oiled machine. Or a well-coordinated kitchen staff, I guess.
I like it. While one chef's on the main course, another's baking dessert.
Exactly. Now, speaking of efficiency, the guide also mentions object pooling as a valuable technique.
Object pooling, super useful.
Object pooling, that's a new one for me. What's the advantage there?
Imagine hosting a party, right? Constantly washing dishes every time someone finishes a drink.
Okay, I see where you're going with this.
That's what happens in games, creating and destroying objects constantly.
Uh,
Object pooling, it's like having a stack of clean plates ready to go.
Recycling, love it. Environmentally friendly.
Exactly. And efficient. Projectiles, enemies, anything spawned and destroyed often. Object pooling is your friend.
Got it. Now, while we're talking about these kind of standard Unity practices, what about those methods, update, awake, start, that kind of thing?
The classics.
What's important to remember about them from an optimization standpoint?
So each time Unity calls one of these, even if it's empty, there's a cost. Small, but it adds up, especially with tons of objects.
Especially over time, those little things add up.
Right, like a leaky faucet, a few drips seem fine, but over time.
Wasteful.
Exactly.
Mhm.
Be mindful. What code actually needs to run every frame?
Don't want to overload those methods.
Now, another area ripe for optimization is how we use Unity's API.
Okay, the API, those are the built-in tools, the functions that Unity gives us, right?
Precisely. And as powerful as it is, some functions are more resource intensive than others.
So some are like taking the scenic route, some are like the highway.
Exactly. Scenic route's nice, but sometimes you need speed. One common example, GameObject. Find or get component in an update method.
So if we're searching for those every frame, that's going to slow things down.
You got it. Cache those results, call them once, store the result, use that throughout your code.
Like looking up a phone number and jotting it down instead of searching every time you call.
Exactly. Now, speaking of handy tools, those LINQ queries, got to be careful with those too.
LANQ queries, those are like powerful search filters for our code, right?
They are very useful, but resource intensive, especially in performance critical loops.
Don't bring a chainsaw to a paper cut situation.
Exactly. Complex data, sure. Performance is key. Be more selective.
Got it. Right tool for the right job.
Now, data files, JSON, XML, that kind of thing.
Common for game data, yeah. What about optimizing those?
One mistake, parsing static data during runtime. Every time the game needs it, it's rereading the whole file, even if nothing's changed.
Inefficient.
Very.
Yeah.
It's like rereading a whole book to remember one detail. Parse that data up front, loading screen maybe, stored accessibly.
Have it ready to go.
Exactly. Scriptable objects, fantastic tool for this.
Scriptable objects, those are like custom data containers within Unity, right?
They are. Store data in a way the engine loves, no constant parsing needed. Like a well-organized filing cabinet.
Easy access, everything labeled. Love it. Now, before we jump completely off the code optimization train, I've heard whispers about these non-allocating APIs.
You're digging deep. Non-allocating APIs. The secret weapon of the performance-minded.
Okay, you got to tell me more. What are they and why are they so special?
So traditional APIs, they create these temporary memory allocations behind the scenes.
Okay.
It's like take out tons of disposable containers. Got to clean them up eventually, add strain.
Makes sense?
Non-allocating APIs, they minimize that. Same results, less garbage for the system to deal with.
Like bringing your own reusable container, better for the environment, better for performance.
Exactly. Lots of physics APIs, for instance, have non-allocating versions. Physics raycast on alloc instead of physics. Raycast all reuses the same array. Small tweaks, big difference.
Gotta love those small tweaks. Now, enough about assets and code for now. Let's talk about the really fun stuff, physics.
It is. It makes those games come alive, feel dynamic, but yeah, got to be super performance conscious there.
Right, because realistic physics, all those calculations, that can really eat up resources if we're not careful.
For sure, for sure. Luckily, Unity's got our back with tools and techniques. The guide starts with, like, understanding those mesh colliders.
Right, mesh colliders, those define the shape of our objects for physics interactions, right?
Exactly. And here's the thing. More complex the collider, more calculations. Detailed colliders look fancy, but they can really drag down performance.
So it's like trying to fit a square peg in a round hole.
Exactly. The more complex those shapes, the harder the engine has to work.
So we want to simplify where we can.
You got it. Approximate with simpler colliders like boxes or spheres. Think of it like using building blocks to, roughly recreate a complex structure.
I like it. Makes those physics calculations a lot easier.
Way easier. And hey, while we're talking physics optimization, the guide also dives into that physics.autosync transforms setting. Ever mess with that one?
Autosync transforms. Okay, that sounds like something that could impact performance. What does it do?
So it basically determines if Unity automatically syncs the transforms of our physics objects. Like any changes to the game object, it makes sure the rigid body or collider follows suit.
So if we move a game object in our scene, this setting makes sure its physics representation moves along with it.
Exactly. Super helpful, but can add unnecessary overhead too.
How so?
Imagine someone constantly adjusting your chair, even when you're perfectly comfy.
Okay, I see. A little too much help.
Right. So in a lot of cases, especially with tons of physics objects, disable it, manage it manually.
Gotcha. A little more control, less unnecessary work for the engine. Now, what about collision callbacks? I feel like those could be a potential bottleneck too.
Good call. Collision callbacks, those snippets of code that run when things collide, super useful. But yeah, got to be careful.
Because if those callbacks are doing too much, it's going to slow things down.
Exactly. The guide stresses keeping those callbacks lean and mean. No unnecessary calculations in there.
Pack light for that collision, right?
Exactly. Speaking of which, that physics.reuse collision callback setting, another handy one.
Okay, reuse collision callbacks. What does that one do?
It lets Unity reuse those internal objects for collision callbacks instead of creating and destroying them all the time. Less overhead.
It's like those reusable shopping bags. Way better than getting new ones every time.
Exactly. Saves resources in the long run. Okay, last physics thing I promise. Got to touch on the layer collision matrix.
Okay, layer collision matrix. Sounds a bit intimidating, not gonna lie. What is it, and how does it help us optimize?
Think of it as like a control panel for your physics. You define which layers can interact through physics.
So instead of everything colliding with everything.
Chaos. No, we want order. Disable those unnecessary interactions.
Keeps the chaos.
Exactly. Okay, shifting gears, let's talk animation. Brings so much life to games, but yeah, performance landmine if we're not careful.
It's true, animation can be tricky, and I know Unity's animator component is super powerful, but when is it overkill?
The animator's great, especially for complex character animations and all. But for simple stuff, fading in and out, scaling, animating a single value, there are lighter ways.
It's like sometimes you need a handsaw, not a chainsaw.
Exactly. A few lines of code, a tweening library, even Unity's built-in animation curves can do the trick.
So choose the right tool for the job. Now, if we are using animators, are there things we need to keep in mind to keep them running smoothly?
Definitely. How we update them is key. Manually updating can sometimes force them onto the main thread, and that's no good for performance.
So we want to keep things off the main thread as much as possible.
Exactly. Let Unity's job system handle it if you can.
Delegate. Speaking of which, we can't forget about the powerhouse of modern gaming, the GPU.
Ah, yes. The GPU, where the visual magic happens. Got to keep it happy.
It's true. What are some things to think about when optimizing for the GPU?
First things first, got to understand how our code, our assets, are impacting it.
Right. Got to know what we're dealing with before we can optimize.
Exactly. GPU profiling, my friend, that's your key. It's like looking under the hood of your car.
Seeing how the engine's running, find those areas for improvement.
You got it. See how much GPU power each task is using. Then you can pinpoint bottlenecks, optimize those shaders, maybe even rethink how you're rendering certain effects.
Makes those optimizations way more targeted.
Way more. And you know what GPU profiling often reveals? Overdraw.
Overdraw. Doesn't sound good. What is that exactly?
Imagine painting a wall, then painting over it again with the same color. That's overdraw. Wasting GPU power rendering stuff the player won't even see.
It's like baking a cake just to throw half of it away.
Exactly. Often happens with transparent stuff, effects with multiple layers. Be mindful of your layering. Look into techniques like alpha testing, Z-buffer optimization.
Got it. Minimize that wasted effort.
Uh,
Now, while we're talking rendering, we gotta talk shaders.
yes, shaders, the unsung heroes.
Mm-hmm.
But yeah, they can cause trouble if we're not careful. Mobile, especially.
So what are some best practices for keeping our shaders optimized?
Keep them lean and mean. Avoid those super complex shaders with a million features you don't need.
Simplicity is key.
Exactly. Don't overcomplicate things.
And what about Unity's camera component? What do we need to keep in mind about cameras for performance?
Good one. Each camera you add, even if it's not the main one, it adds a little overhead,
Which can add up.
right? Especially on less powerful devices. If you've got multiple cameras, maybe for UI or something, see if you can consolidate or find more efficient workarounds.
Makes sense. Now, batching, I've heard that thrown around, but I'm not entirely sure I get it.
Batching is super cool. It's all about grouping similar objects so they can be rendered with fewer draw calls.
So, efficiency through grouping.
Exactly. Unity has tools for both static batching for things that don't move and dynamic batching for object sharing materials.
Sure.
Organize effectively, less work for the GPU.
Nice. Okay, last but not least, when we talk rendering optimization, we got to talk LOD, right? Level of detail.
Ah, yes, LOD, our good friend.
Yeah.
Use simpler models for distant objects. Why waste resources on details you can't even see?
It's like using a thumbnail for a faraway image instead of loading the full resolution thing.
Perfect analogy. Fewer polygons, fewer draw calls, especially in busy scenes, it makes a huge difference.
So many little things that can add up to big performance gains. Now, we've covered a ton of ground: assets, code, physics, animation, rendering. But there's one crucial aspect of game development we haven't touched on yet: the UI.
Ah, yes, the UI. Can't forget that. So important for the player experience, but often overlooked when it comes to optimization.
It's true. We spend all this time making the game look beautiful, but if the UI is laggy and unresponsive, it can really ruin the experience.
Absolutely. And, the guide really stresses this. UI optimization needs to start early. It's not something you just tack on at the end.
Yeah, it makes sense. Just like with everything else, thinking about it up front saves headaches later.
Exactly. Now, one of the first things they talk about is scaling, screen sizes, resolutions, all that.
Right, because we want our game to look good on everything, from tiny phone screens to those massive monitors.
For sure. And while Unity's UI system is pretty good with responsive layouts, you got to test it, tweak it, make sure it works everywhere.
Can't assume one size fits all. Now, what about Unity's canvas component? That's like the foundation of our UIs, right?
It is. But here's a tip. Avoid those monolithic canvases.
Monolithic canvases, those are like those massive Unity scenes we talked about earlier, right? Why are they a problem for UI performance?
Any reason? They can create bottlenecks. One element needs an update, it can trigger updates for everything on that canvas.
Ugh, not very efficient.
Nope. Break those UIs down, multiple canvases, group elements logically.
Makes sense. Easier managed that way. Now, layout groups. Those are super handy for arranging UI elements, but I've heard they can cause performance issues too.
They can, especially when they get nested.
Nested layout groups. Those are like those Russian nesting dolls. What's the issue there?
Imagine every time you move the smallest doll, you got to adjust all the bigger ones too.
Tedious. And probably not very efficient for our UI.
Exactly.
Uh,
One change can trigger a cascade of recalculations. Use them wisely. Consider alternatives if the layout doesn't change often.
Got it. What about large lists of data? Like inventory screens, leaderboards, those can get pretty intense.
They can. The guide talks about using a pooling system there. You only create enough UI elements to fill the visible area, then recycle and reuse as the player scrolls.
So it's like this constantly moving conveyor belt of UI elements, just enough to display what's needed.
Exactly. No need to create and destroy elements constantly. That just bogs things down.
Smart. Any other UI optimization tips we should keep in mind?
A couple. Be mindful with those mask and rect mask 2D components, the ones used to clip UI elements.
Okay, to make them fit certain shapes.
Exactly. They're useful, but add overhead. Use them sparingly.
Gotcha. Anything else?
Last one, and this one's simple but effective. Disable that raycast target on UI elements that don't need input.
Ah, so if it's not clickable or interactable, no need to check for those events.
Exactly. Saves processing power. Small tweaks, big difference.
It's all about those small tweaks, isn't it? Well, I'd say we've covered a ton of ground today, from those initial planning stages all the way to fine-tuning the smallest details.
It's been quite a journey through Unity optimization. Assets, code, physics, animation, UI. We really did a deep dive today.
We did. And hopefully everyone listening now feels equipped to tackle those optimization challenges head on. Because remember, it's an ongoing process.
Absolutely. Keep analyzing, iterating, find that balance between performance and, of course, that amazing player experience.
Exactly. So, with that being said, go forth, use these tips, and create incredible high-performing
We
games.
can't wait to see what you make.